There you are. There you are.
Turn off your mic. I mean, enable your. Oh no, that's his mic.
I want to turn off my camera and share my screen.
Yeah, I would actually turn your mic down.
Are you hearing?
I'm in full blast, but I guess we're
okay.
No, it should be good, unless it's clipping.
Am I just loud?
Fine. Loud
okay.
Is good. Awesome.
Hi, everybody. I got 3 badges for Aaron Peterson, Kay Lau, and Sean Watt.
Oh, that's pretty better.
Huh?
Trade you, let's see. Yeah, I'm watching video.
Oh, so you're sharing a screen now, right?
Yeah.
Trying to get the angle right here. Oh yeah.
There we go. Instant regret. Clive had some intros. He should use Jeff's computer then too, so we're all set up with the same computer.
Yeah.
And get your computer hooked up.
Yeah. Yeah, let's get him up there.
Okay.
Pizza's here.
I'm Jeff, by the way.
Jeff, I'm Jason.
Nice to meet you.
Hi, Jeff, I'm Mike.
Hey, Mike. One presumes that means you guys work here.
I do not actually.
You do not. Neither of you.
We're all organized for the.
Oh, okay.
And I happen to also.
Oh, okay. But so you're still wearing a guest badge just to.
Just to confuse things, I have.
Right.
I am a.
Because it's meta, yo. This is the one that's on. Okay.
So.
That sound.
Oh.
What's the URL that Clive has up?
Why don't you go to this academic?
So we're gonna set this computer up for everything.
Yeah, I have a lightning talk to present, but I can just click these links.
Okay. But it's got to be on this computer, so it's all screen tab.
There's a Bitly link as well. Bitly.camlistore.
All one word.
Not only go cam li.
C-A-M-L-I.
Right.
Yeah, we'd like to use one computer for this, so it's joined with the Hangout.
Do you have the PDF online or anything, or?
I can send you a Dropbox link or something.
Yeah, sure. I had too many pockets. Oh wait, it's not shared. You're on thinking of being so cool. No. There is that. And then for some reason iTunes wants to do its thing. I could probably stop that. Install and relaunch.
Take away, hang out on there.
Okay, what's your? Okay. JHULTEN @gmail. Does holding down the @ not just bring up the list anymore? At least it used to in email addresses, you hold down the @ and it would come up with like @gmail, @me.com, @hotmail for the really common.
I just know that they added the common dot extension to the
Right, pizza. No, that would probably be very helpful. Yeah, they did that as the theme for DevOps Days a couple of years ago. And then had, during the social one evening, they did had a live band playing.
Really?
Yeah.
That sounds pretty awesome.
It was pretty good. Although it got a little noisy in the space that we were in, but.
Been faring now that
Still get 30 or 40 people. It depends on the week and or the month and what type of event we're. Oh, just nice cubes, good.
no. Okay.
We actually have 3 events this week that all tie together. We have your talk, kicking it off. Google Startup Developers Week, Seattle. We have, I'm going to talk a little bit about Camlistore because that's a bunch of things they're doing, which ties it into the Google Cloud Platform, which is based here. And then the third thing is there's the Kubernetes workshop later in the week, which kind of, gets more into the management. Meetup on Thursday. Saw that. Yeah, I saw that. Yeah. Yeah. Thank you. We should mention that I'll try and mention that.
I figured I should ask if you're giving this talk. Part of the reason I'm here is I'm scouting for people to talk about Go.
Okay.
I'm trying to get Go Meetup Seattle 75. Kind of.
Is that the one that's playing Thursday with the?
Yeah.
Okay.
Yeah. And I was wondering if you
I could be interested. I mean, this is really a gateway drug talk.
Oh no, so I know
right.
this is definitely very introductory, or at least that's how it's built. And so this certainly, it doesn't have to be you. But
you know, I'm going to try and build up some members of my team to be. I've got some introverts on my team, but they're also being brilliant and good at what they do. And you know, I would love to get them to the point where they're comfortable presenting and talking about the stuff they're doing. One of the guys is the Terraform from HashiCorp is basically, you know, it's the like genericized AWS cloud formation, right? That can go into multiple backends.
sure.
He's wrapping up a plugin to drive our Riverbed load balancers through Terraform.
Sure.
So
That
he's
sounds pretty
currently writing more production Go code than I am.
particularly, yeah, network heavy,
Mm-hmm.
at least concurrent, if not parallel stuff. It's pretty interesting.
Well, and one of the things that I'm looking at is
Yeah.
our CLI tools, basically putting a smart enough Go front end on that where we have a single, you know, because we're Whitepages, WP space
Sure.
and whatever subcommand
Sure.
with the ability to go fetch thing. You know, if you
Have
say
you heard
WP
of,
build and you don't have WP build installed in your machine, it goes
Yeah.
and fetches it and brings it down.
Have you heard of Cobra Commander?
No.
So it's a CLI tool. I just got introduced to it. I guess it's called a commander, which is like Go or something
Mhm.
like that, right? So you can have an arbitrarily deep tree of subcommands
Okay.
that are defined, and it's just sort of a library for managing putting that together.
What's it written in?
It's written in Go.
Okay.
Yeah. So it uses like P flag and some library that I think was, I don't know. It uses a bunch of other like Go libraries.
Mm-hmm.
So it does like it's one thing and it focuses on it pretty hard.
Right.
But
I've been using Code Gangster's CLI
okay.
library.
I'm sure there's like probably 4 or 5 different CLI libraries out there.
Mm-hmm.
But yeah. That sounds really awesome.
We'll have to talk.
Okay.
Oh.
Everything you need.
Thanks, man.
I can get it to you guys.
Mm-hmm.
I think that's all you're going to need.
So how much attrition do you guys plan for based on your reservations? About 50%, or so you get like 147 people signed up, and then
Yeah, I usually about. It depends, like, so you get like, because we've been splitting between Brooklyn and here,
Mhm.
and you get a different group of people in Brooklyn than you do here. It's weird. Might have to
because nobody wants to go over the bridge.
come on, but I go. It's once a month. What are you gonna do? It takes me an hour. Yeah.
So you know each other, right?
We do now.
Okay, good.
Yeah, 147. We'll get about 7.
And there was 11 from the film meetup. I don't know if somebody reserved 11 spaces.
Or if they all, double booked, or who knows what that actually turns out being.
Huh?
So we have one at 6:30, like you said. People, we don't usually get to where we're going to be at. I was going to get it started.
Yeah, I run the Seattle DevOps meetups, and we start, basically the doors are open. I'm in in our great room at 6. I pull the covers off the food at 6:30. People socialize, and then, start at 7. But it's also, we often will peak out at 35 people. We're almost at the point, if we grow anymore, I'm going to have to stop doing, having everybody introduce themselves, which will suck.
Oh, wow.
We're doing, for a while it was, who are you, what do you do, and question, some kind of question about yourself. So it's like, it's the beginning of the new television season. If you watch television, what are you looking forward to? And if you don't watch television, what are you doing with all that time instead? Right.
No, you have to actually.
Well, it means that there's some, you end up losing a little bit of the everybody knowing each other that you can, get in a smaller group, but that's also okay. Where do you work? Pretty collections?
We were just bought by HP.
I'm so sorry. I mean, that's great.
You got it.
The HP open source cloud group.
Helium now.
Okay. Brian Akers, and he's not there anymore. Mark. Last name just left my head.
It's Ron. He's there.
Okay.
He's the new guy. He's the one that's getting over from.
Well, and is Hernan still over there? Hernan Alvarez?
I think so.
He used to work at Whitepages.
Actually, wait a minute. I think it was a different guy. I don't know.
Okay.
A lot of it is a new team.
Mm-hmm. The sun is trying to kill you? Or as we refer to it, the day star?
Yeah. Well, I came to Seattle. You're in the right place. Yeah, it's easier to hide here. Who's this trying to me for 6 months at a time?
I have a friend of mine who was born and grew up in Hawaii, but he's of the Norse heritage, and so he's constantly like, I have to go in and get more precancerous cells cut off my body. So I gotta want to find that T-shirt and give it to him. If nothing else, it'll give him something entertaining to wear to his next dermatologist appointment.
Yeah. Now go back to the presentation. I think just slide over. He's full screen. Go back to Safari. I think he's got it on one of his other tabs, maybe.
I think he's got it. Let's see. Yep. So we just unmuted you, but I'm trying to find the presentations. Are they on a different browser? We want to turn the microphone down a tad.
Oh, okay.
Probably definitely with you. Are you theater trained or opera trained?
Theater trained. Okay. Input volume somehow got bumped way up. Is that better? Is that better? Okay. I should probably have, be not facing away when we test it.
Is the Camlistore on there as well?
Mm-hmm. Yep.
That's the best way to get to that.
And the other tab.
Okay.
Let's go to the top. And we can
just click over.
Mm-hmm.
Okay, thanks.
Hard stop.
Yeah.
I don't think so.
Hi, everybody. Finally, we're ready. Yay. Okay, so tonight we have a few announcements, a couple of lightning talks, and then Jeff's presentation. Just to kind of start this off, I just want to talk a little bit about some things that are going on with Google Developer Group Seattle. So we have in November, we're not having a meetup like this one, we're having a DevFest meetup, which is something that Google does in the fall season, like in October and November. So currently going on all the way around the world is the October season of DevFest, which is everything to do with Android L and wearables. So there's a lot of meetups. If you look at developers.google.com, there's a whole bunch of meetups there. And we opted, it sort of had a little bit of a choice. We opted to do a Polymer DevFest. We thought that might be more inclusive, get more people who, we didn't think too many people have the Android L phone and so forth. So we went for the Polymer. And so there's some information up here. It's actually already posted on the website for the November meetup, November 15th. And so the event is a hackademic, Polymer Hackademic. So it's basically a day here in this, actually I think it's in this room here at Google on a Saturday, November 15th. And it's a bunch of code labs. So we're going to walk through a bunch of code labs with some tech talks, and we have some cool speakers. And then there's also like an extended code lab after lunch, which is kind of a little bit more freeform, so you can go at your own pace. So, and what's cool about the Polymer is, that you can extend, you can build web components that are useful to include in other frameworks and other projects. So we're going to have a full day dedicated to learning about that. There is a nominal charge. There's a $10 charge. That's mainly to cover his food, since we'll probably have we'll have breakfast and some lunch, so we need to kind of figure out how to cover our expenses. So I'd encourage everybody to kind of sign up for that, or if you know it doesn't fit your needs, perhaps just help us spread the word. We do have a poster. We're going to post this, a link to this on the meetup, and you can just download it. So if there's anybody here from, say, the University of Washington or Seattle University, if you kind of just print one of these out and put this somewhere where students will see it, we'd love to kind of bring students as well to the hackathon. Okay. So,
what do you want?
Let's see.
You're right. It's not doing what I expected it to.
So as you can tell, Jeff is a great driver.
Okay. What you want?
Yes, thanks.
So, another thing about this week, kind of very special week, is this week's actually Seattle Startup Week. It's kind of like just the news is kind of just getting going. I think it's the first time we've had a startup week with a very developer focus. And there's a few things going on this week that sort of tie that together. So I wanted to talk a little bit about Camlistore. And this is a product or a project which is written in Go. And it ties together some of the activities that are going on here at Google. It ties together the Google Cloud Platform and a bunch of other stuff. So I thought I'd just kind of go through this. And then after this, I wanted the folks who've got some other announcements or lightning talks, when I have you guys come up, and then we'll switch over to Jeff. So I've given this talk a couple of times. And actually, the very first time I gave it with at Linux Fest Northwest. And Jeff went ahead and gave a Go talk, and I followed up with a Camlistore talk. Now, I'm not an expert on the product. I'm more of a fan, very passionate about the product, so I can talk a little bit about it. It's a product. Okay, so it's led by Brad Fitzpatrick. He actually, and this is my talk is almost. It's a big talk, but I actually just got a few slides to share about it. And I've done a reprise of his FOSDEM talk, which is a big open source project in Belgium. So what Camlistore actually looks like is this. It actually looks like a little bit like Instagram on the UI, because it actually uses React.js on the very front end of the product. And it's designed so that you can do, it's almost like a social backup, where you can back up or collect the content that goes up into all these different social applications. You can basically make your own personal data store. And so the way Brad describes this is that, in the future, like donkey's years from now, you perhaps have like a family photo album that you'd share with your grandchildren or something like that. And in the past, you've always had like hard copy photographs printed out. Well, one of Brad's rationales for producing this product is to produce a product that sort of collects all those very special moments, and you can back this up onto your own server, and you can put it into the cloud, or you can put it into your own server, or you can keep it on your phone. It's got a lot of choices to it. So that's just kind of briefly what the UI looks like, and you can see it's got synchronizations with Twitter and Foursquare and Flickr and some, I think, Google Photographs. How did Brad get going on this? He got going on this because he was actually traveling between San Francisco and Google Mountain View, and it was he didn't have a good internet connection, so he started making this product to make his own sort of personal CMS, and he'd written a couple of CMSs in the past, and he just laid out this folder, content addressable multi-level index storage, and that's spelled Camlistore, and so he just kept going with it because it's somehow the name stuck. He registered the domain, and he's got the .org and I guess probably the .com. Don't know. Some features of Camlistore. Yeah, I mentioned it's personal data store for life. It's like Git for your own social backup. It's a little bit broader purpose than Git, but security is private by default, so you get to decide who you share your content with. So if you just kind of wanted to share your content with your children and maybe some relatives, you could just do that. So it's kind of got a lot of peer-to-peer type potential to it. It uses the Fuse file system. It does data versioning over time, a little bit like Time Machine in Apple. It's the snappy UI, which already kind of gave a picture there. It's got different clients, which are available in JavaScript, Java and Objective-C. And the deployment, I'm going to come to this in a moment, but they're really working on the deployment. It's going to be available on Google Cloud Platform soon. So, and it will run in Docker. So there's, of course, it's got some pretty high standards. They're targeting the two most recent browsers and the two recent versions on Android and iOS. So some goals. It's content addressable. It's searchable. It's got a web UI, and the point about this is the majority of it is pure Go. So that's kind of like a little bit of a sort of segue into, and I think, I'm not sure, it's a great, I thought it would, the one reason I wanted to share this is this is a great repo to learn from. So in my particular case, I'm not like a great developer. In fact, not particularly good developer at all. So I'm better off at picking up a project and modifying that project rather than starting something from scratch. So that's why I like to play around with Camlistore. Okay, why did he choose Go for Camlistore? So just some rationale. He felt that Perl and Python were too slow and single-threaded, and C++ and Java too tedious. So we went with Go. It started as a 20% project, so apparently these 20% projects are still active at Google. So where you're spending like sort of about 20% of your time. The idea, since he was working on the Go team, was to kind of also improve the standard libraries for Go while developing sort of Camlistore. So it's a little bit of a relationship between the two. This is kind of really wanted to cover in the lightning talk today, is that easy deployment is coming for Camlistore. So right now it takes me like probably about half a day to do the deployment. You've got to set up your own instance on Google Cloud Platform, but it's actually working on, for folks who are not don't want to spend the time doing that. And the other thing I noticed is that quite oftentimes we'll come to Google and they'll give us one of these certificates or some credits to use the Google Cloud Platform, but then you've actually got no application to launch there. So it's like, how do I use my credits? And then by the time you figure something out, your credits are run out. So it'd be nice to just have something like an application just run straight away. And that's what he's working on, is a 4-step easy install. And that's going to use a whole bunch of technologies which are on the Google Cloud Platform, the GCE, MySQL, cloud storage, the Core OS, Docker, and the nice thing about Camlistore as well is it encrypts your data, so which is kind of another nice benefit. So a little bit, my last slide. So what he announced today is and by the way, there's already about 67 contributors to the Camlistore project. There's quite a few Googlers. And they're migrating the product away from, I think, from code using Google is the main repo to using Git. So if you go to this particular link here, what it'll do is you'll actually authorize if you've contributed to the product or done and it'll actually give some credits. I'm not quite sure how this works. Somebody probably else knows a lot more than me. It'll actually give some credits to GitHub to kind of host Camlistore. So they need to like pull a whole slew of data, all the issues, all the history of the product, all the open issues and closed issues, and history about how it's being built. And if you click on this link, it'll actually provide those credits. And when they've got enough credits there, they're just going to move all the code over from open source into Git. And then I believe they're also going to scale Git and do some automated builds and testing and so forth. So if you're going to run on Camlistore on Azure or on GCE or AWS, there'll be a lot of people contributing. Need some additional information about Camlistore. It's just camlistore.org. There's a nice, pretty active Twitter site where they have some nice pictures that there's people add capabilities to the product, and actually wrote the Wikipedia page for Camlistore, which is Wikipedia Camlistore, and it captured kind of some information there, which is not elsewhere. So that was my lightning talk. So I just wanted to share that as a kind of a little bit of a takeaway product that's written in Go that also works with the Google Cloud Platform, and is a sort of a bit of a segue into Jeff's talk. And so that's me done, and I wanted to see if there was some other folks who had some talks or some announcements.
From the future here. Good evening. My name is Abtin Furuzende. I'm the Director of Software Engineering at Spectranetics. I'm here to talk about some of what we've been doing. There's two really main purposes to my talk. One is to just share some of the techniques that we've started using at Spectranetics, and the other is Go has developed a reputation in any online discussion within the first few comments. Some cowboy will attack Go for being a web-only language, or only good for web apps, or only good for servers, and that's just a bunch of hooey. So at Spectranetics, we are a startup defense contractor, and we're using Go in support of national defense objectives. We build tactical spectrum warfare systems, electronic warfare, signals intelligence, communication systems, and radio frequency direction finding. We don't build weapons yet. Everything we do is custom, from the hardware to the software, everything we do. A lot of FPGA stuff that we do. So the military faces new threats appearing, well, I should say the customer faces new threats appearing all the time. And we rapidly build new systems in response to what they face. So we write a ton of new code, and our systems, from conception of hardware to delivery and actually fielding it, this all happens on the order of months as opposed to years, which is probably what most military projects do. So there's an example of what we've built. This is a direction finding system. So we have these really cool antennas that will tell you the position of every emitter, the frequency that they're emitting on, the direction in both azimuth and elevation. The front end is HTML5, but the back end is all written in Go. This is something that didn't exist a year ago. So why do we pick Go? Well, you can write it really fast. You start thinking about a problem, and you start writing code. You don't have to think about how to use the language at all. It just goes very smoothly from top to bottom. But one thing that happens when we're rapidly iterating is new hardware requirements get added on, new features get added to the system. And in every other language, this becomes very kludgy. No one has time to properly engineer a system on a very short time scale and make it work and make it be readable. Go routines and channels come together to fix that problem. Because in Go, when you have a new feature you want to add, you throw it in a Go routine, and it has a channel that it communicates out of. You have a main thread that, well, you have a main Go routine that's handling all of the actual heavy lifting. And so what ends up happening is you've added a new feature, but its actual impact on the overall complexity of the system is very low because there's one channel where it's injecting data into the system, and you can handle it from there. So the way we now think of applications is that they're a composition of Go routines. It's kind of archaic to think of an application, at least as we build them, and I think this applies to many server applications, as having a single business purpose. Instead, it's a set of processes that are working together. And it's sort of taking the traditional Unix idea that you have small specialized applications that you can put together. It's taking it to a slightly lower level in that we build specialized libraries that we then put together, and in very few lines of code, we can do new things. There's two types of Go routines that we really think about. Primary and supporting. Primary are, they consume information, they drive the business logic, whereas supporting tend to supply new information to the system. They don't really talk to each other. So primary things are things like control and monitoring. They can't really run in a degraded state. If they break, that's not good. The system can't do what it's intended to do. And if somebody really want to take on an awesome project and write like a control and monitoring library for Go that runs in a Go routine that you can just plug in and have it start and then monitor that thing forever, you should do that. Supporting Go routines, it's okay if they break. It might be undesirable, but things like in our direction finding system, we hook up to a GPS and a compass to provide offset. So our antennas are mounted on vehicles usually, and based on the heading of the vehicle, we want to adjust the reading you see. So it's okay if that breaks. Yeah. So this is basically what all our main functions now look like, and it's getting cut off a little bit. But I'm sorry if you're not terribly familiar with Go yet, you will be with the next presentation. We drop all pretense that there is one central driving purpose of the program. We initialize a bunch of Go routines, tell them to go, and then what you don't see here is that there's a select statement at the end of this main, so that the main thread just pauses forever. Ooh, look at that technology. All right. Yeah. So that select just makes it pause forever in the main thread, but you have everything else going on. In terms of distributing data, people like to get very complicated and fancy and do things like pub/sub and multi-writers and a bunch of hooey. We don't have time for that. So we just create channels and then manually hook up everything within the application. This makes it way easier to debug. We don't have to worry about, oh, there's a bug in the pub/sub library. No, there's no time for that. And then a huge benefit of Go, and this is what actually allows us to use it, is we can talk to hardware. So many people are under the impression that Go can, you have to use CGO if you want to link to C, or if you want to talk to hardware, if you want to do anything with the DLL. You do not. Go is amazing. You can, this looks complicated, but once you get used to these functions, it's actually not. This is a wall of text because presentations suck. In real life, this is nice and formatted. So yeah, this lets us do DMA. We can write to registers. We can read hardware. We can do all kinds of stuff here. And in our systems, we don't wait for receivers to get data, because in direction finding, or if you're looking at a spectrum analyzer, which is a new WebGL thing we're doing, you don't care to get all of the data. You just want the latest data, and you want to stay up to date. So one thing that Go makes very easy, which is kind of hard in other languages, is if the receiver isn't ready to get the data, if your WebSocket client isn't ready, you have the default case, it hits, and you just continue on. I will handle questions at the end, if you don't mind. We can build up these new applications with just a library of specialized functions that we built over time. There's no need to worry about versioning. We let Git handle that. Whereas if we had multiple applications, like one thing talking to hardware, another thing providing DF data to an HTML5 client, that you'd have to worry about all kinds of issues there. We don't. We just let Git. The dependency versioning stuff in Go is not as big a problem as everyone makes it seem online. You just do it correctly. Use Git. You point to a repo. You point to a specific commit. And probably one of the biggest benefits is that we have one consistent log. So the part earlier where I said it's a myth that now applications have one driving business purpose, that was a lie. They do have one driving business purpose, and in most deployments, you have to look at a lot of different logs to decide what happened in an application. With Go, you don't, because you can combine all of the disparate areas of functionality into one executable and have one consistent log come out. And I'll finish up here real fast because we're a bit over. Probably the biggest problem is we don't write tests because we don't have time for that. And we don't actually expect, if somebody decides to buy a bunch of our systems, we'll do things correctly then, but we do tons and tons of prototyping. And Go, while I suppose it's 1.0 or 1 point whatever now, while it's released, I have no confidence that our current code will run efficiently or even correctly in future versions of the runtime, because like the garbage collector is going to change in 6 months. I don't know. Crashes. The downside of the approach of our current approach is that if any Go routine crashes, if there's a panic anywhere in the app, everything dies, even if we don't really care. Like if the GPS stops working, that's fine. I don't care, but it'll kill the app. That's it. Any questions? Yes.
So would you say you had a front end that wasn't Go that's talking to your Go backend?
The front end is HTML5. We use web technologies. I'm sorry. Yeah. So what languages are we using for the front end and the back end? So the back end is all Go. The front end, maybe one day it can be Go. That'd be great. But at the moment, it's whatever web technology is available. So in the DF screenshot I showed, that was D3. We're using WebGL for showing spectrum and yeah. All right. Thank you.
Yep.
So who else has got some announcements? Jeff, you want to get set? Well, I'll get set.
Hi, I just had a quick announcement. My name is Thomas. I am the organizer for the Eastside Android Developers Group, the other side of the pond. So we have a meetup in beginning of December entitled Getting Started with Amazon AWS SDK for Android. And we have somebody from Developer Evangelist from Amazon coming there, and he's just going to go over their entire SDK for mobile, all their mobile offerings. So yeah, I just wanted to announce that it'll be held at the T-Mobile headquarters in Bellevue. So I'll leave some flyers on the back with links, and you can sign up to Eventbrite. So that's it. Thank you.
So Jeff, as you explained, that doesn't really need so much introduction, and it probably doesn't need a microphone.
That is accurate. I was asked earlier, so are you operatically trained or just theater trained? Just theater trained, thank you very much. So my name is Jeffrey Hulten. I'm a newly minted engineering manager at Whitepages, running our developer tools engineering team. We are tasked with basically attempting to grease the skids between a commit and a deployment. And we're looking at our existing tool chains and the tools that are available in the world in order to try and make that happen. Most of the services that we're consuming, or rather deploying, are written in either Ruby or Scala, but both of those have their drawbacks for anything that needs to happen on the command line. So I'm going to talk today about learning to write Go. I'm going to assume who here writes in some language, and I don't mean English. Okay. Who here writes in Go? Okay. If I screw up badly, tell me later. I get embarrassed really easy, so I'm just kidding. I always try and give people an out. However, I'm the only game in town at this particular event, so this doesn't necessarily apply to all of you, but if you're going to like tune out and play Angry Birds or Candy Crush on your phone for the next 40 minutes, here is my parting hint, and then you can stop paying attention, and that is when you Google for Go, don't Google for Go. It's a terrible search word. Google for Golang, and I even provided a let me Google that for you link. But the first thing I want to talk about in this is about simplicity. Now, it's always entertaining to start a talk about learning to write one language by quoting the creator of a different language. This is Rich Hickey, who created Clojure, which is a Lisp on the JVM. It is common for people to say, Lisp and Lisp people are weird. But you can say the same thing about Ruby people. You can say the same thing about Java people. I heard someone say, Java's just simpler. But the thing that he pulled, and that I pulled out of one of Rich's presentations up on InfoQ called Simple Made Easy, where he talks about the difference between things that are easy, in other words, near at hand, either easy to understand because we already know them, or easy to get to because we have constructs in our head that already match our expectations, and simple, which is to be not intertwined with other things. Great talk, by the way. Is that we program with constructs, but we're in the business of artifacts. And every time our constructs get in the way of delivering the artifact which we intend, we're probably making the wrong choice. So people are like, Ruby, it's so beautiful. I can write my code and it just flows. It sounds like English. It's like poetry. But, writing multi-threaded Ruby, I don't want to do that, man. That's a terrible idea. Go is a language for concurrency. Go is a language for our modern problem set. And our modern problem set is we're not going to get bigger CPUs, we're going to get more CPUs. And anybody who looks at, you look at Moore's Law, we thought Moore's Law was going to break, and then they just started sticking more CPUs on an individual core. However, those individual cores haven't gotten appreciably faster. We've gone from 3 to maybe 4 if we're lucky, but now finding 4 cores on a desktop is not a big deal. Do you think that your out-of-the-box Ruby or Python program can take advantage of that? Probably not. But first, I want to start you with the easy way. Everything needs a hello world. Luckily, Golang provides a playground at play.golang.org where you can enter code and hit run and get a result back. Now, there are some caveats. The time is always, I think it's either 1 second before midnight or midnight on the epoch. So you're either a Unix time of, is it not anymore? Oh, is it 2006? Oh. It's always the same time, which will actually bite us a little later in one of my later on demonstrations. You can't bring in external libraries because they don't want you to blow up their machine. They want you to learn a little bit about Go. So, and I think you can only run things for 10 seconds long. But if we look at this particular block, a couple of statements here, and what at least to our educated eyes looks like a function. If we hit run, we get the expected exiting code. If we hit format, well, nothing changed because I didn't screw up the formatting. But if I screw up the formatting, and hit format, we get it corrected. This is going to come into the last piece that I'm going to talk about at the end of the presentation, which is the tool chain. But one of the things that you will find if you read Go code, you're like, this all reads like it was written by the same guy. And that's because there's a common tool chain that's built into the tools called Go format that enforces the same standard formatting practices. Never again will you have an argument with your coworkers on whether or not the curly brace belongs on the line with the function name or after the line with the function name. Whether or not you're allowed to build your for statements in particular ways, that's all defined inside of the format. So let's go through this particular file line by line and see if we can make some sense out of it. The first line there, package main. We are declaring the package for the file. Likewise, you'll notice this is a single layer package name. This package name is specifically how libraries will call. If this was a library as opposed to an application, this would be how a library would call the exposed method or functions inside of here. This does not necessarily mean that it's the namespace path of where you got it off of GitHub, which we'll get to in a few slides. We then import another package. We import the format or FMT package, which is part of the standard library. The standard library for Go is kind of a thing of beauty. It's been a long time since I saw a standard library that I was willing to write production code with out of the box, including the HTTP server. We declare a function called main. Main, in this particular case, if you have a main function inside of a main package, you're defining that this thing is an executable, and that's the entry point for your executable. And then we call the function println. Notice the capital P, we'll get to that in a bit, from the format package using dot notation, and pass it a parameter. Packages, this is the first part of that, right? We specified that this was package main. You'll notice we're doing that again. We're using import format, and I'm importing math_rand. So you'll notice here, I'm doing math/rand, but once I get down here, I just use rand. Because math_rand will tell me what thing to go import, but the name of the library itself is just this last portion. So the math_rand, if you were to look at the Go source, would say at the top, package rand. So this is an idiosyncrasy that might bite you. If you try and put a slash in here and do a fully qualified name thinking you need to do that, it's not going to work. There are ways to alias these to other names, and even to import them into your local package namespace. That's outside of the scope of this. You can use your Google foo as you see fit. So I'm going to randomly select an integer between 0 and 10, probably non-inclusive. And I'm going to get that my favorite number is 1. So what happens if I run this again? That is a very unrandom random number. And that's because the random number generator is being seeded with the time, and the time is always set to the same value. So we would have to change that. And I'm going to use my Google Foo here. Let's find this and say, go package math/rand. I have other ways to get to it, but here's rand. And I see here that I have a seed function that provides the seed value to initialize the default source to a deterministic state. Oh, if seed is not called, the generator behaves as if it's seeded as seed 1. So that's actually what's happening. It's just always taking seed 1. So, well, I've gone too far. So let's say rand.seed. Oh, now my favorite number is 6. Now, if I actually wanted to do this right, I would also import time and use the local timestamp. That's not going to help me any. But I can make this 22, run it, and I get a new secret or a new favorite number. So you're noticing a couple of things here. There's some patterns that might be starting to jump out at you. And those will be validated as we get a little further on. External packages. This is one of the simple beauties of Go, where they said, you know what, we're going to do the easiest possible thing that could work and do all the hard work in the back end. When I import format, I can also import a library based on a URL. And that is the path to the source repository. We can support Git, we can support Mercurial, we can support, did you shake your head at me?
No, my laptop just died.
Okay, are we reconnecting the internet? So in other words, people can still hear me, or? Okay. Okay, so I'm basically playing it blind to the audience, as it were. I wouldn't help to use my camera anyway, they just see this. So, so in this particular case, I'm pulling code from the GCFG library, which is hosted on code.google.com. When I build this package, if it is not installed already on my machine, Go will go and fetch the source for that package, download it, compile it to its intermediate objects, and statically link that in with my application. I'm defining a type. We'll get into the types in a little bit here, but if anybody who's done C probably recognizes a kind of a simple struct. In this case, we get a nested struct, which is a field called name, which is a string, and a flag, which is a Boolean. And then I get to create an empty version of that config, and I get to call GCFG just like it was part of the standard library using the last portion of this name. There are some gimmies and some gotchas. You're not pinning versions. There are tools that are outside of the standard chain, tool chain to support this. GoDeps is one of them. Govin will then, GoDeps will basically it'll create, in essence, like are there Rubyists in the house? No Rubyists. Java people in the house? Okay, a few Python people in the house? Okay, so the Python people, it's like your requirements.txt with equality version specified. For your Java people, it's like a pom.xml, but you're getting very specific versions. You don't get any variable version numbers of Maven anyway, because that would be like modern. But it's going to create that lock, and then it's going to vendor all of those files in so that you can check them in as part of your repository. So even if the repository, the library that you were relying on is deleted off of GitHub, you still have it inside of your source code. Govin, then G-O-V-E-N, kind of like Coven, does the magic of then taking your, one of the things it can do is take all of those links where you specified the outside path and rewrite them as the paths that you have in your vendor directory. which then means that you're relying only on yourself, which is kind of nice, but that's batteries not included. However, one of the things that was brought up by our friend who taught me the syscall package existed was, will it run with the runtime? Well, once you've compiled the binary, it's statically linked. It's not dependent upon an outside thing. So as long as he's storing his executables, it doesn't matter if we go from 1.2 to 1.3 until he needs to compile it again. Once he needs to compile it, you know, mushroom cloud. But and then the last item is that we have a lot of assumptions that people come into the Go community and go, I just want bundler. I wish I had bundler, or I wish I had, you know, Ivy, or I wish I had NPM for Go. Go's a little different. Go thinks a little differently. There's different ways of handling some of these problems. The Go community has different values in the way in which they're approaching certain problems around versions, around you know, the statically linked nature of things really changes a lot. Imagine if you could statically link all of those .rb files in your Ruby projects and just stick them in with the rest of your code. That would really change the way in which you wrote things. But you can't. So we have a different set of problems, and a lot of people have tried to write, there's a like GPM, which would be the Go package manager, which is based off of NPM and has all of the warts of NPM without any of the, you know, benefits of it being the intended platform for it. I think somebody wrote something, called it Gundler, because, you know, naming things is hard, so why not just change a letter? There's a great argument article on nathany.com about Go packages, where he lays out a lot of the arguments about why this isn't your mom's dependency management problem. Now, if you were noticing as I was writing, or I was going through code, and you were looking at all of the method names, you saw some capitalization that might have seemed weird to you. Because normally, when you camel case things, the first character is lowercase, but it wasn't the case. Every time that we pulled something in from format, fmt.P println, because in order for something to be public in Go and available outside of the scope of the local container, it has to be capitalized. There's no private keyword, there's no public keyword. It is quite simply, if it's capital, it's public, and if it's lowercase, it's private. Now, you come from the outside, you know, other programming languages, you're going to go, that's nuts, that's crazy, and then you start doing some Go, and all of a sudden your public functions in Java start with capital letters, because it makes sense. Once you realize that this is such a simple way of disambiguating between the two, you can tell every time you look at a call, you know, is this a public or a private function, even if it's within the same module. So when you start looking at extracting functionality from one monolithic module into two modules to reuse stuff, you can go, oh, I'm relying on these three private things. How do I expose those? Types. We've given you the crash course through the package management system. Now let's talk a little bit about the type system. Golang is a statically typed system. I am a dynamic language junkie, but I still use it, which means that there must be something good under the covers. When you specify that you have a var of I, which in this case is capital, would be exposed outside of the package, you say that it is type int. You create my string, my is lowercase, so it is private. Assign it a value. Notice in the first case, I didn't assign a value. In the second case, I'm providing a value. One of the very same things that Go did in its language design is that a allocated variable that is not provided a value gets its zero value. So in the case of I of int, type int, and I didn't provide equals 1, it defaults to its zero value, which in the case of an integer is pretty obvious, it's 0. In the case of a string that I don't pass a value to, it's an empty string. This carries through the rest of the application, including to pointers. If I allocate a pointer to a thing and I don't say, you know, or a pointer of a type, but I don't say what thing it points to, it defaults to a null pointer. And the null pointer is protected enough where, yeah, if you call it, it's going to throw an error, but you're not going to get magical behavior. This is part of how we can write potentially safer code in Go than we can in, say, straight C. Because when you allocate anything in C, for those who are not familiar with that particular piece of arcane history, you get what was ever in the memory space by the last person who wrote it, even if that was gamma rays. You know, turn your box off, turn it back on again, and everything's set to kind of random noise and bits, might be zeros, might not, who knows. But that's also where you end up with people who say, well, I'm going to force this thing to actually take this other value and then, you know, dump out the entire contents of, you know, these pages of memory, which may or may not include SSL certificates and keys. So there's a little bit more protection here. The last version here, I'm specifying that there's a file reader and an error. So you'll notice that functions can return have multiple return values. And I'm using colon equals. Colon equals will set the type and the value. It'll infer the type out of from the return values of the function that or from the right-hand side of the equality. So os.open returns a file reader object, not object really, a file reader typed variable and an error. If it does not actually fail, that error is nil because it's the zero type. So you'll often see this behavior where I'm like, I'm going to call this thing that is, you know, this return value and error. And then I'll say if error is not equal to nil, then obviously something really broke and I need to go handle that. The other great part, I've included links here. There'll be this is all up on my GitHub, and I'll tag this with today's date so that you could find this particular iteration of the slide because they change. But Golang has a very specific specification for the language, and I've included all of those at the bottom of these pages. So struct type, how many people are familiar with struct, OpenStruct, done C structs? You know, it's a thing that has fields in it. So, you know, like, but I'm an object-oriented programmer. Where do I put my fields and my properties together? Well, this isn't really an object-oriented language, so you kind of don't. You end up with a struct that has fields in it. And you can attach a pointer to that struct, and you can do all, you know, kinds of fun stuff inside of that struct. But when you pass it around, you're passing around a reference just to that data, or a copy of the data, depending on how you call it, as opposed to passing around a heavyweight object that has a lot of behavior attached to it. However, you're like, but that's crazy. I need my behavior with my object. We'll get there. There's a way. So I've created a tiny struct, which has one field called isTiny, which is public and is of type Boolean. I then instantiate it 3 different ways. First, I create the zero version, the null version of zero value version of the tiny struct. Zero value version of a struct is basically the struct with the zero value version of all of its fields. I think that the zero value version of bool is false, but I'm not certain. I'm getting a nod from somebody who's probably does a little bit more of this than I do, at least in the wild. The second version of this, I'm using in-order arguments to basically instantiate this struct. So I'm not providing the names, I'm just providing positional arguments. Since isTiny is the first field, the first true goes into that place. And then the last, I use key value pair, so I can specify that I want this particular field to have this particular value. I can then access those values using a fairly traditional dot notation, but you'll notice this is I'm using a capital I. Now, if I switch here, we're going to see, maybe that was a bad, I should have made one of those lowercase. Let me go back up. If I made that lowercase I, everything inside of that package would be able to get to that field. So even though the struct is public, its fields can be private. This is actually the way a lot of libraries work around pieces that you don't actually need access to. Like, you need to be able to call read byte from a file stream, but you don't need to have the actual file handle. We don't want you mucking around at the file handle level. If you want that, write your own, reader. So this is how you end up hiding some of that abstraction. You also have the ability to take these structs and embed them inside of other structs. So I've created a new my struct. The first line says tiny struct. Well, is that a field name? There's no type. Well, provided that it is non-ambiguous, I didn't double negative that, good. Provided that it isn't ambiguous, my struct now has, as you see down here, an isTiny field. But I can also specify the fully qualified name that I want the isTiny that's down the tiny struct path. So now you have this ability to take structs and build larger structs out of them. So maybe you have a struct that is an address that you build inside of a struct that is a person. And then you can call person.city or person.zip, provided that there's only one zip field for that entire person object. I also have the ability to nest structs inside of structs. So, this is a struct with tiny struct. A is a string. B, oh, I did make it lowercase. I knew I was smart enough to do that. B is an unsigned 32-bit integer, but it's private. No one outside of this package can see it. And then I have another field called nested, which is another struct in and of itself, which includes C, which is imported from another package. Likewise, as before, I'm making MS, I'm allocating the 0 version of it, I'm setting values, etc. Then I can have other struct, which has mstruct as my struct. So I can actually take my structure and assign it a field name, and then it's no longer embedded into the parent. It's underneath the tree. So if you wanted to have both work address and home address, you could have an address struct that you use in 2 places, one as work address and the other as home address. And as you see, I get this, since I'm continuing from the previous page, other struct has value mstruct, or has key mstruct, which I'm assigning the value my struct with the field isTiny set to false. So I'm actually nesting my way all the way down through the structs that we've seen so far. Functions start with func. Likewise, if they are capital, they are public. If they are lowercase, they are private. You provide your argument, space, type, comma, argument. Wait, did I make a typo there? No, I didn't make a typo there. This is actually a little bit of shorthand. Both arg1 and arg2 are of type int64. So if I have a whole bunch of things that are all of the same type, if I don't provide a type on the first one, it will say, well, I'll just borrow the one from the guy down the road because that's what you meant. I also have the ability to get a list, or what's called a slice, inside of Go. This is values is now a kind of array slice. There's multiple terms to search for of ints. In this case, though, I have a return value, which is an error. Or here, I have no inbound arguments, but I've named my outbound argument. I had a lot of discussion with a couple of my coworkers about whether I should even mention this, because this seems to be kind of one of those things that people do and then it bites them in the butt. But there is enough code out there that does this where you need to know that it happens. I personally try and avoid named return values. It seems to be a little abstracting and magical as opposed to empirical. Functions are also their own type. So I can create an anonymous function and assign it to a variable. So now f is that function. Now we get into the part where I get to make all of the, I get that old, was it Carl Sagan that did the old GIF that's everywhere, mind expanding, mind blown. The way in which you do object-oriented things in Go is not by creating an object. They're all just structs. What you're doing is defining an interface. And an interface says any type which provides functions that match this definition is also this interface's type. So most interfaces are action words ending in ER. So I have an interface here at the top that has a do thing method that returns an error. I called it a thinger. So now I can instantiate thingers, except that I don't really have an actual concrete type called thinger. I just have this interface defined. But I have my struct that I defined earlier. The moment, you'll notice the one other case which we hadn't mentioned yet, if I put it in the beginning of this, I'm basically saying this is the receiver of this function call, much like your embedded, this is a method. The moment that my struct has a doThing method that matches this signature, every instance of my struct is now also a thinger. I can pass thingers as inbound types. So I can specify that a function takes a thinger or returns a thinger. And I don't have to care about the actual implementation underneath there. All I know is that that thing that comes in, that concrete type has these functions available to it. This is how all of the I/O package is a great place to start. How all of the I/O package is written. I also have other struct that I've now defined here, but I've done it a little differently. Any C programmers in the office? Yeah? What does star mean in C? It's a pointer. Yes, Go has pointers. Run away, it's scary. Yeah, but you can't blow up the world like you can in other places because these pointers are statically typed. You can't assign a pointer to a foo to a variable that's supposed to hold a pointer to a bar. It's not allowed. You can have pointers to pointers. It's pointers all the way down. What do you think is the difference between MS and OS in this particular example? Now in MS, it's a type my struct. In OS, it's a type other struct. That's obvious. But if I were to mutate MS and I were to mutate OS, do you think there would be a difference? Well, there is. In the first case, because I'm not passing a pointer, I'm passing a copy. So when I hand it to you, you're not getting a reference, a pass-by value in that particular case. So you get a full copy of it. If you mutate that, when you exit your function, that copy is gone. In the second case, since I'm passing a pointer, I'm passing you a link to the actual thing. Now, how I use it in code is identical. So I don't have to think about the semantics and unwrapping the pointers and whatnot, because as far as calling functions on interface or on various types, whether it is direct or it is attached to a pointer, is identical. And as I show down here at the bottom, I can pass this now as a type and then call t.doThing inside of my method. Then we get to the empty interface. If I create an interface that has no methods attached to it, no method definitions, well, that should match everything, right? It does. This is what makes the dynamic language programmer in me happy. I have the ability, when I absolutely need it, to pull out the magic sauce. I can burn myself badly with it. This is not, This is not gazpacho, this is piping hot soup. So in this particular example, I've got package main, I'm importing format. I create a type called any because I also do Scala from time to time, and there is an any type in Scala which matches everything. So I've recreated the any type from Scala. And then I create a variable called I, which is of type any, and a value of the integer 1. And then I keep a variable j, which is of type any, and it is a value of the string 1. And I create a variable of type k, which is of type any, and the value of the floating point 1. And then I println each one of them. 1, 1, 1. Wait, I did something weird here, didn't I? Well, let's pull that out and see what happens. Oh, apparently it didn't friggin' do a thing. Why did I do that magic? This is what happens when there are too many months between when you write the presentation and when you give it a second time. What if I do that? Hey. Okay. So I have a single type that can be cast to various things. I have the ability to manipulate its return type, call casting. I can change this to a unsigned integer of 32 bits, and then get a nice error message saying constant 0.1 truncated to integer because I had an integer at the beginning of it. Your head's exploding yet? I'm getting quizzical looks. We might be hitting people's tilt points. Well, let's get to the good stuff. Why would we use Go as opposed to anything else? If all I'm doing is writing, there are days where I say, screw this, I'm going to write this in Bash because I know it'll work. And because I need to not be able to bring in outside dependencies that can screw me up later. But if you're in Bash and you're trying to do a bunch of background processes, that's such a good thing, especially unless you want to try and do funny file, handle magic to attach the file handles, the standard error and standard out and standard in for all of your backgrounded processes to, no. Go routines are the answer to how we do two things at once. But a quick side note. The difference between concurrency and parallelism. Concurrency is about dealing with lots of things at once. Parallelism is about doing lots of things at once. So if you think about the barista at your Starbucks, the barista at your Starbucks has 3 ways of doing business. They can take your order, make your drink, hand it to you, then take your order, make your drink, and hand it to you. That is neither concurrent nor is it parallel. They can add a cashier, take your order and then take your order, and those orders stack up, and she starts building the individual pieces, but is still only ever doing one thing at a time. The barista is only pulling one shot or steaming 1 cup of milk, even though she might interleave the order in which she builds the 2 separate drinks. Or we go parallel and have 2 baristas. Once you have 2 baristas, they can either do things in parallel or interleave multiple orders from across the room. Understanding this is kind of key to understanding the various challenges and how things actually need to happen in your application. If you don't understand whether you are talking about a concurrency problem or a parallelism problem, then you're going to have a hard time reasoning about the debugging that comes along after it. If you want more information, I've got a link to a Vimeo talk by Rob Pike, one of the guys who wrote Go. But I want to give you an example. I've created here a little program. Package main, import format, import time. I then create a function which takes a string called from and iterates 3 times, printing out from, colon, and the number of the iteration, and then sleeping 10 milliseconds. I'm going to call that thing directly. I'm going to call it in a Go routine. I'm going to call an anonymous Go routine that just prints out the word going. And then I'm going to sleep 100 milliseconds, and then I'm going to be done. So if I run this, I get direct 1, 2, go routine 0, going, go routine 1, go routine 2. So the direct is going to go directly up to the function. We're in the main line of execution. We iterate through 3 times, printing out direct 0, direct 1, direct 2, and then we exit the function. No concurrency has happened. In the next one, we specify in the background that we're going to call the function f with the value go routine, and we put the keyword go in front of it. That passes the execution of that function off into basically out of the main execution path of your application. I then can also create an anonymous function, which is what I'm doing here, that just prints out whatever message. I'm then sleeping because what do you think happens if there are things executing in the background and my main loop exits? Would you expect it to wait for everything to finish? Or do you expect it to just stop? Well, I can show you. Comment. It stops. None of the Go routines get a chance to run. Well, Go routines don't provide you a handle back to your main running process. There are other ways to handle that through channels and run groups and some other. These are phrases that you will search for on the internet. But there is not a thread allocation. There is no thread to join to. These Go routines could execute forever. So you don't necessarily, if I have a Go routine that has an inbound channel and is talking out syslog to my syslog server, what do I care if it, as long as it's processed its last message, what do I care if it's in a wait state? Just exit. Just let it die. Which is the really goth version of Frozen. Let it die. Let it die. So I can, for example, call a standard function that sleeps for 100 hours in a Go routine. 100 hours will pass, the Go routine will exit. The Go routine will not return because there is no point for the Go routine to return to. You are not making a subroutine call. You are spawning a parallel thread of execution, not even thread, a parallel routine of execution. I don't know if there's magic hiding inside of CGO that allows you to do stuff, but there's they may be actually, the other one, they may actually be threads, but that doesn't mean that the language semantics as far as the specification has changed. So it may actually be a thread under the covers in the other version. That actually kind of scares me because that means that you're spawning a lot of threads, which is not the point. So in this case, this next case here, I'm creating an anonymous function, assigning it to the variable f, and then I'm calling go f with open parens in order to activate it. I can also call that anonymous function directly. But notice that my ending curly brace is followed by the parens. Otherwise, I'm passing an anonymous function to Go, which is not what it expects to have happen. It expects to have an actually called function be passed to it. There are some gotchas. They don't block. They do not prevent the main thread from exiting. You are responsible for managing your own destiny when it comes to concurrent access. However, there are plenty of pieces inside of the standard library which work really quite well for doing that, including the sync library and its mutex type. and you have no one to return a value to. So you end up using channel, which we'll get to in a second. Anyone's brains ready to explode with types, packages, and Go routines? Yes? How do you find out if a Go routine crash is the question. Right. So you have various ways of affecting the outside process, and you don't have the concept of an exception. You have the errors, like I talked about earlier. You can basically throw a fatal error, which will trickle up the stack towards the running process, and you can put, in some cases, a try-catch block around your Go routines, or not really a try-catch, but basically the function of a functional equivalent that says, when you get a fatal, this is how I want you to resolve the problem. You also have the ability to do what is called a defer, which I don't know if I'll get to or not, which basically says, when this routine exits, do this thing after the last instruction. So if you're going to open a file, you do os.file open thing, and then defer, let's say we put that in F for file. Defer f.close, which means when my function exits, it's going to close the file. It doesn't matter whether that's exited because you ended up with a critical fault or normal behavior. In either case, you will close the file. So you have these semantics for capturing these erroneous conditions and doing the right thing. But you're starting to get into areas that I haven't touched enough of the edges of to really get a great picture of how to make an analogy out of it.
That's the other question on Google+.
We have a question on Google+. What is the question?
The question is, could you compare Go to Scala? Just a little.
Sure. Actually, I'm going to leave this as an exercise to the reader, but I'm going to make it a really easy exercise for the reader. Follow what I do in my slides for the hello world in Go, compile that. Create a hello world in Scala, compile that. Run time and the necessary path to execute, and check the difference in how long it takes to purely start up the VM, the virtual machine, print a single line out to standard output, and close. And for a lot of the tools that I'm looking at using Go for, that's my answer right there. The JVM by itself has gotten much, much better as far as how it captures or how it, the speed up on startup. But there's still, the JVM then has to, load all of the Java or the Scala classes and everything else on top of it. You have the ability in Scala with the Akka libraries to do actors, to do similar types, though not exact parallels in concurrency. It really depends on what your desire is and what problems you're trying to solve. If you've got better library support for the thing you want to do in Java, that may be the answer right there. Because Scala is going to give you access, interoperability with Java where Go is not. At the same time, if I have a purely high concurrency problem, my personal belief, and I have not benchmarked this, is that I'm actually going to get between execution, basically the throughput of execution, how many concurrent requests I can handle, against size of executable, which when you're in a microservices or many services environment, you're trying to push bits around to start up and tear down things, quickly becomes a concern. I think those are pretty big winners there. The moment you want anything that is able to run on multiple platforms, well, as long as they're supported platforms, you can probably get away with it with Go, but maybe not. If you want Erix, go write it in Java. Because basically you get FreeBSD, Darwin, Windows, and Linux, and 386, AMD 64, and ARM, and those are your choices. Hopefully that is sufficient for you there on the internet. All right, channels. Channels are themselves a type. They are also a strongly typed bounded queue. So a channel is a type, but a channel which passes strings is also a type. So you can say that I take a pointer to a channel. That's not particularly useful because you want to know what type of thing you're passing around on it. Your argument types can also indicate direction, which is to say, I'm going to pass this to a function, and I'm only going to allow inbound messages. I'm not going to allow that function to read from this channel. They can only write to it. There's a great post on the Golang blog on pipelines, which is where most of the rest of this comes from. Let's go for it. We'll make a channel. And I'm going to start by creating a variable called ch of type channel of type int. So this is a channel that passes integers. I'm then going to call make, which is going to actually instantiate the channel. I'm going to build its data structures, if you will, in the background. I can also, when I call make, pass a size. If I don't pass a size, then I have a size of 0, which is to say that I as one Go routine can put something into a channel, and my process or my path of execution is blocked until someone takes that thing away from me. So you have a primitive synchronization mechanic there that you could potentially take advantage of. But I can also provide it a size, which says I can now put 10 things on there, and I will only block once the 11th goes on. This allows you to build systems that provide back pressure. To say, I know that my database, that I'm passing my queries through this channel, I know that my database can handle about 25 concurrent connections. I want the 26th request to the process that's going to handle the database request to just tell it to back off and to wait until it has its turn. If you want to send to a channel, use an arrow. So in this case, create the channel. It has a size of 1. I then pass 1 to that channel. You were so smart, Clive. That is going to return immediately. That is a non-blocking operation because my channel has a size of 1. It can take one thing and not block. Provided that there's no one on the other end of that channel, when I try and pass 2 to it, I will then block my execution until whoever's on the other end of that channel takes something away. In which case, the 2 will enter into the channel, and I will be free to continue executing. Anyone want to guess how you take things off of a channel? Well, I'm just going to point the arrow the other direction. Or rather, I'm going to put the channel on the other direction of the arrow. In this particular case, I'm taking a value off of channel, and I'm assigning it with its type to C. So since ch was a channel of type integer, C is now going to be an integer. This is a blocking operation that will wait until something comes into the channel to take from it. This is often how you'll end up building these types of systems that he was talking about earlier, where you have multiple components that have one input-output channel pair to talk back and forth. It starts up and it sits there and goes, great, I'm not going to do anything until you tell me to. Oh, I should take this log message and do something with it. Okay, now what? I also have various other ways. There may be a bug in this, actually. I don't remember. If you spot a bug and tell me about it, I'll give you 2 of my little gizmos that I have to give away today. I'm going to create a channel of size 10. I'm going to put 4 items on it. And then I call range on that channel. It will iterate through every available value on the channel, printing off the square of that number. Because here I'm taking ch, its value is going to come off of the channel and be assigned to n. I'm then going to square n as the entering value to println. I'm seeing nods. Good. You also have a select. This is the one that has the bug. So no bonuses for you. I create my channel again of type int, takes 10 items. I create done, that is, takes channel boolean. I then put in 1, 2, and then pass true to done, and then 4, and then I do this select loop. Now, does anyone see what my bug is? You spoke out without raising your hand, so I'm going to call on this guy first. Now, here's some of the magic of select. Select randomly chooses the order in order to prevent you from ending up in a case where you are depending on, when you're making bad choices and depending upon the select state. No, I created a channel called done that has no size. So I'm going to put true on done, and I'm never going to put 4 on the channel. Because, and I'm never going to get to the select because I'm blocked. So in this select, I then take cases that say, if there's something available on this channel, then do this thing. If there's something available on that channel, then do this other thing. This is how you would do that type of exit that you were talking about. How do I tell a message to a Go routine that it can be finished? Well, you provide it with either, the magic word, a type that is like the poison pill. If you want to have only one input channel, say, if I pass you a thing that is a poison pill, then you die. But more often, I would just do this type of done channel pairing, because I'm going to have, that done channel is going to be attached to a shutdown function that's going to be, a fairly clean and small piece of code. Yes?
If you had put one on the channel, you have no idea how much will come out.
You are correct, sir. In the second case here, I'm pulling from channel CH and I'm assigning that to N. And then I'm squaring it as I did before. Nods, good. And they don't appear to be sleepy nods. Even nods from the guy in the back. Way to go. I'm just giving you a hard time. You're obviously, you get the throwback to the cool kid sat in the back of the bus. Or you're a recruiter and don't actually want to be so close to the rest of us, one of the two. So channels are types. They can be passed in and out of functions. I'm going to create a function called generate that takes a list of integers and returns an outbound channel of type int. I'm going to create the channel out with a bounded 0 size channel. All channels are bounded, so you can't create an unbounded channel. You could probably create a channel of size max int, but that'd probably be a really bad idea. I'm then going to create this anonymous function that's going to take in items from nums, which is this passed in list of integers. And range in this particular case is going to return index and value, because I'm calling it against a slice or array. But I don't care about the index, so I'm going to assign that to the magic underscore, which basically says, I know there's something here. This is a placeholder. Just ignore it. I don't care. And then I'm going to take n. I'm going to pass n to out. And when I'm done, I'm going to close out. So I'm going to close the channel. This is the other method. If you can tell when work is done, you can send a close to that channel, and then there are particular semantics that boil up in how a closed channel returns values. And then I'm going to return that out channel. So now I've created a function that's going to hand me a channel that gives me one at a time the integers that I put into the function. I can also pass a channel in both in and out. So here I'm going to create a function called sq for square. I'm going to take in a channel. an inbound channel, or a channel that I can read from that passes in integers. I'm going to return a channel that other people can read from that passes integers. And create my own out. I'm going to again create that go function. I'm going to create the range for in. Since in is a channel, I only have the one value. I don't have an index. And then I'm going to pass to out the square of n times n. Once I'm done, I'll close out. And then I'm going to return out. I can then take these things and pipeline them together. So if we assume for clarity's sake, I'm going to spell it out. Square is the previous definition of SQ. Generate is still generate. I'm going to pull from the outbound of this outer squares, the channel that I get out of square, calling range on that. That's going to assign that to n, and I'm going to print it out. The value that I pass into that inner square is another square, and the value that I pass to that inside square is generate 234. So in this particular case, I will pass 2 for the first square out. It'll get squared to 4, and then that'll get passed out one more, and it'll get squared to 16. And then that will be passed out to the main function and be printed out. The actual ordering semantics are a little trickier because as you take things off and start processing them, that potentially frees up, if there's a context switch in the background, another thing could put something new onto those channels because you're unblocking the other paths of execution. But you don't care about them because they're isolated from you. Your only channel of communication is this channel, which means you don't have to worry about it. I would then pull the 3, it would turn into 9 and 18, I'd pull the 4, and it would turn into 16 and 256 if I'm doing my math right. So that's channels. With those two semantics, we have all kinds of really powerful stuff that we can do, limited by your imagination and the currently available hardware at the time. Questions on channels before I get into the next piece? You know, I'm not entirely certain. The language is, so the question was, how does, when you allocate a bounded channel, let's say size 10 or size 80, how does it break that up? Does it pre-allocate it? Does it grow and shrink, etc.? I don't have the specific details on that. I know that they're available, but the question quickly becomes the semantics of back pressure in larger queues. Usually, you know, if you remember your queuing theory, what is it? I no longer remember. It's obviously way too late for me to remember. But you know, the more that you put on the backlog, you actually end up having, you know, other semantics as far as you're better to tell the guy upstream to wait a little bit and to not just keep spewing more stuff at you. So, you know, when I'm building these types of systems, I usually try and keep my channel sizes pretty low, but it's also going to end up being one of those things that you tune. So you're like, oh, let's start with a channel size of like 1 so that I can get it hand off and keep going, and then we'll see what happens next, and then maybe I'll make it 10 and I'll see what my performance is, and oh no, I've exceeded the ability of the system to keep up with my demand. So yeah, I'm sure that the curve will end up being some kind of yeah. Yes. You got it. The range keyword acts on things that can be treated like arrays. So if you think of it in this particular case, the range keyword is saying, I have a channel and I can treat that as a linked list. I'm going to take the first thing off the list, and then I take the next thing off the list, and I take the next thing off the list. And if I try and take a thing and it's not there, I'm going to block until it is. then I would assign the channel, not the value that is on the channel, to n. Anything else? Yes? Say again? So the question was, what is the overhead when people are trying to take stuff on and off the channel at roughly the same time, and how they trade back and forth? In the simplest case, if you're running a single thread of execution, then obviously it's context switched. If those are operating in their own threads and their turn comes up, there's a mutex type thing in the background. But actually, what happens under most conditions is that you've put the thing in the channel and your job is done. And you get one of two behaviors. You either get to continue processing, or you're forced to context switch because there's no more room on that channel for you. If you have a size of 0 and you put a thing onto the channel, it's in the channel. There's no longer a contention over that. Only if you have more than one consumer on the other side. Right. So I believe that that's internally mutex protected, but if you're doing something where you're spawning up multiple Go routines to consume a single channel, you might have a design problem. You might be trying to do too many things. I would far rather see it go to a single Go routine that fans out to multiple, fans out individual pieces of work to multiple, subsystems of its own, and then gathers those back up and does the right thing. Yes? I don't believe so. I don't believe that I have the ability to, because the intent is basically that this thing is bounded, but bounding is okay and expected, right? You can do it in the select.
Yeah, so it just won't write the channel at all.
Okay. So talk to him afterwards. He apparently knows how. Common tool chain, common practices. Don't you wish that your favorite? Oh, you still got one more, huh? Last one.
Actually, let's stay on this one. The question is that if I actually have dual consumers and there's something on the channel, what happens?
If you have two consumers consuming from the same channel and something on the channel, both of the consumers are blocked. Just like if it was one consumer.
And if the channel has no depth, then I have no idea.
Well, because the consumers don't, right, you don't know which one's going to get it. So in theory, those consumers should better be the same piece of code. Right, because otherwise it's, you're not getting the behavior you expect. You're getting, roulette.
Yeah. You could spin up a bunch of workers that are identical, just to get more processing power out of it.
Potentially. So what I could, imagine that I'm creating a network stack. My expectation is that I would create a channel that I could pass. I'm going to have something that binds to the inbound port that says, I'm listening. When you connect, I'm going to package up all the metadata about you and pass you off to a worker. Now, whether that is a single channel with multiple workers on the back end, or that gets handed down to a single worker that then makes other decisions based on what it should do there, that's a design decision. Okay, common tool chain, common practices. This is one of the things that I like most about Go, and part of it is because I'm quickly approaching 40 and I feel my inner curmudgeon rising. I'm about 3 scotches and a really bad day from sitting on my front porch in a rocking chair, polishing my shotgun and telling kids to get off my lawn. But I don't want to be that person. That's not who I want to be as an individual in the latter half of my life. I don't like that guy very much. So when I find a tool that makes my existence a little happier, not necessarily from the writing code perspective, but in the all of the drudgery around, everything else. I expect that my work is going to be work, but I also expect that my tools aren't going to get in my way. So there's a common tool chain in the Go world, if you're using the standard Golang packages, that give you a lot of this just kind of peacefully and magically without having to worry. Go clean. Delete all of that extra crap, object files and whatnot, from compiled objects in source directories. Never again will you have to write your own make clean method that goes and finds the right types of files and RMs them. Go get. Well, this sounds like it might be pretty obvious. This goes out and fetches things off the internet. It's going to download the packages and their dependencies. So when I go and fetch one library, I'm then going to look at the things in that library and say, the imports in that library and say, oh, it also needs this other thing. I'm going to go get it too. Go format. My favorite. This will prevent you from ever arguing again about where the parentheses or the curly brace goes. This is why it looks like all Go code was written by the same boring didactic individual. Didactic? No, that's not the right word. Pedantic, that's a good word. That's a better word. Many editors, by the way, Vim included, which is my editor of choice, I can actually set it up to run Go format on save. So save the file, go format it, reload the file, which means every time I save, I get properly formatted code, even if I got it wrong. Go build. Create a binary. In this case, I can pass in the output and a bunch of build flags and specify which packages I want to build, including the ability to say, in the current directory, go into all of the subdirectories and build all of the things. Now this will compile libraries into their appropriate intermediate objects, or if there are main functions inside of main packages, it'll create binary, executable binaries out of those. Does not, however, install them into your bin path, so you're not actually overwriting anything. Go test. How many people have wasted time trying to find the right place in the test subdirectory hierarchy for the piece of code that matches up to the piece of code that you're trying to edit? Well, in Go, it's pretty simple. You take the file name, you add underscore test.go instead of foo.go, it's foo underscore test.go. That's your test file. Go test compiles all of the things that include underscore test and then runs the test suites in them. You get a summary of results telling you which packages succeed, which package fails. You can pass the same range, kind of collective object, test everything in this subdirectory, including it, everything in this directory and its subdirectories. Oh, by the way, I don't know if you noticed this last line, can contain test functions, benchmark functions, and example functions. So you can actually write examples in your test suites that then get included in your documentation, but are compiled to make sure that they actually work when you run your tests, so that you are not communicating the wrong way to use your code with your downstream developers. One of my favorite examples of this, it wasn't in Go, I believe it was in Groovy. A friend of mine wrote one of the Groovy, learn Groovy in not 21 days, but he's way better than that. Programming Groovy, probably for maybe Prague or something. And he was flying into a city to do some consulting work and was handing off the transcript or the manuscript in the morning to his editor, and he gets an email. Groovy 2.5 released. All of his work is done on 2.4. Like, crap. Wait, I wrote unit tests for every example in my book. Upgraded Groovy, ran his unit tests, everything passed, got a good night's sleep. Yeah, it's amazing the ways in which testing can save us time, even in the oddest places. Actually, I think that testing is often even better placed in suited for documentation work than it is almost anywhere else. In real code, it can often become brittle and have bad side effects, but being able to say, this still applies to this new version in the documentation because I can test all of the examples is a real boon. Go install does the compile and then takes those packages and installs them in the bin directory. Pretty simple. I can also go install a particular GitHub URL. This would, for instance, install Michael Crosby's SkyDoc, which is written in Go and links Docker containers and their IDs to DNS. So when you spin up a Docker container, it puts that in a DNS tree that you can look up your neighbors using DNS. I want to try and leave you with a little bit of pizzazz, a little bit of, you know, get the blood back flowing again. Top 3. I'm no Letterman. I can't give you a top 10, but I can give you top 3 hints for Golang that don't include, I don't think, oh yeah, hey, I didn't start with search Google for Golang, not Go. So that's a gimme. These are my next top 3. This is like my 2 through 4. Don't think in traditional objects, and this is hard. Like, I know that I am attempting to approach this particular problem differently, and I still end up screwing it up. Think in behavior of interfaces instead, and being able to pass arbitrary items that meet behavior expectations rather than classes. Try the standard library first. If you need to do something, look at standard library. It's the only standard library that I know of where the HTTP server can be used for production work, and is. NetHTTP, which is the standard lib for HTTP servers in Go, is used, last I checked, to power downloads.google.com. I can't imagine trying to do that with WebRick in Ruby, or frankly, any standard library that I can think of. And then learn to love channels. Once you figure out how to make channels do the right thing for you and to behave the way you expect, and kind of to treat things like passing messages between independent paths of execution, suddenly there's a lot fewer things that you have to think about because you're not, you know, maintaining shared state. You're you know, working in an encapsulated world. You've got a lot more happy things to work with. Got a bunch of resources, including Reddit has actually got a good Golang community. It's not super active, but I find a lot of good blog posts and stuff there. And then the Google groups, Golang Nuts, the effective Go on the Golang site, and the spec under ref spec. Questions? And I'll give you a couple of, chance to vent your questions while you could still remember them in the middle. I'll let you think for a moment while I take a drink.
So you mentioned that a blank existence can match everything. Is there a way of figuring out like if a float is an interface with nothing in it, can I figure out what it is? Basically,
I think that there's some stuff with there's a reflect library that gives you some visibility into that, but I haven't had a problem set to dig deep enough into that. The question was, if you've got that kind of empty interface, any type, how do you tell what is actually the thing that you're being passed?
something like parsing.
So parsing JSON is actually a whole separate kind of way in which all those structs that you saw, there's a function that basically says, give me a struct and give me the JSON, and I'll parse the JSON and put it in the struct, and I'll use the struct and the format of the struct to infer what fields I should be getting stuff out of the JSON. So I can show you an example of that a little later if you like, but it's actually pretty cool. Bueller? Yes? No dumb questions. Depends, as I understand it, on the compiler, but the standard Google provided Golang compiler, it is a lightweight execution process space. It's not a Unix process. It is not a thread. It is something that is in this in-between space that can then get scheduled. There is a what's the word I'm looking for? You know what? I'm going to exit out of here. And no, I'm not going to go that deep into the. Here we go. First, let's give me something big, and then let's give me something clean. I hate people when they change code badly. That's some Go code. And let's go to I'm just going to make a directory here and we'll test something. Remind me your question again so that I make sure that I get it right. Right. So there is a, stop that, there we go. There's a value in runtime called gomaxproc. It can be set as an environment variable. You can set it internally. By default, if I remember here, gomaxproc variable limits the number of operating system threads that can execute Go level code. So if you have a gomaxproc of 1, your Go routines are basically still single-threaded. You do not have parallelism, but you do have concurrency. So you can hand work off to, one channel can get blocked, and then the work gets handed off or rather one Go routine can be blocked, and the other Go routines can switch over and start taking over work. There's no limit to the number of threads that can be blocked in system calls on behalf of Go code. Those do not count against the gomaxproc limit. I don't remember what the default is, but last I checked, I think it was actually set to 1 by default. So you have to intentionally turn on parallelism. Gomaxproc. If n is less than 1, it does not change to this current setting. The current number of logical CPUs can be queried with num CPU. So often what I will end up doing when I'm writing a piece of code for production, if I'm going to write a service, I'm going to say, find out how many CPUs I have. If I'm sharing this machine with other people, or I know that I have operating system stuff that needs to be able to happen as well, or, and it's over 4, subtract 1, because that way the logger can still keep up, and set my gomaxproc to that. So if I got 16, run 15 gomaxproc. Make sense? Cool. Yes? So the simple favorite thing about Go is just the ease in which you can take existing code, put the keyword Go in front of it, and make it run in the background. That's pretty freaking cool. The more complex, and if you're talking about the more kind of what's an esoteric cool thing, the thing that I've discovered in the background that kind of made me go, oh yes, data race detector. So I can run, test, run, build, or install with -race, and it will basically permutate the various ways in which my code is executed to look for race conditions. When I found that, and then found and fixed like 6 bugs in my code that I hadn't, including 4 of which that hadn't erupted yet because I just hadn't quite gotten the right set of conditions, that made me a very happy man. Because usually those are the bugs those are Heisenberg bugs, those are bugs that you have to discover in production, not things that you can necessarily find easily. Yes?
Could you Vim? You have to use like an IDE?
So there's a whole argument of, you get to a certain point and Vim becomes your IDE. I often find, especially when I'm playing closer to the edges of languages, that Vim and Emacs get far more functional support far sooner than any of their compatriots, possibly because of the complexity of implementing a functional set of tools in Vim is a far lower barrier. You know, it's like a weekend project for a really pissed off developer. And usually that's what ends up happening. Like the current set of Go tools that I'm using in Vim was a guy who looked at the existing set of Vim supported tools and went, yeah, this isn't enough. And used that as a starting point and added a bunch of new Vim script to make things better and then push those out. Go also included in its support directories a standard Vim package and Emacs package, I believe. So, yes. Do I use a debugger? Personally, my debugger is often Mark 1 eyeball combined. Well, actually, they're kind of Mark 2 because I had to augment them slightly. It just didn't live up to the labeling on the package. But combined with writing, part of it is how you write your code in the first place. I have found that, especially when you're dealing with parallelism, one of the traps is you try and put too much behavior into one set of parallel work because you think threads are expensive, but you're not actually using threads, so it really doesn't matter. So once you get past that and you start breaking those independent chunks of execution into far smaller components, they become far easier to test. Bugs become shallow as code becomes shallow, even to one set of eyeballs. So my debugging technique is far more about my coding style than it is about any particular tool set. That being said, as I understand it, you can attach GDB to the running process. You just have to be able to figure out what's Golang VM components and what's your own code. 5.
So early on you mentioned the shift to concurrency. So it seems that probably in the next 24 months we'll probably have a phone with a lot more cores.
So the question is about phones and cores. We've already got phones with 2 cores. So, yeah.
So just looking into the future, at what point does the number of cores on the phone probably trigger a movement to Google perhaps using Go instead of Java on the phone? All you need is a UI, right?
Let's do a Google search, shall we? Golang Android. State of Go language for Android native development. So apparently, there's a proposal to add partial Go support for Android apps. The thing to remember about Android in particular, I'm not going to speak to iOS because frankly, who knows what the hell they're going to do, is that you're not actually running Java on it. You're writing Java, that's getting compiled to Java bytecode, and then that's getting transpiled from Java bytecode into Dalvik bytecode. So they already have a VM that is specific to running on phones, running in low power situations, providing security and compartmentalization. What is preventing them from taking those components and writing a transcompiler from compiled Go code to the Android VM? Engineering hours and enough care to actually make it work. And a UI. However, there's some interesting things. I came across a deal today, Go bin data, which is a small utility that allows you to generate Go code from any file or file system. So now you can take an entire HTML-based UI, generate Go code from it, and expose it into an HTTP server on localhost. Once you've done that, then you run your service to basically talk to the front end, and you put just enough stub on the front end to pull up a web view, a WebKit view of your front end that is all compiled into your Go code, and you're done. Oh, and then that same pile of UI could potentially be reused by users on the iPhone platform, but they have to go to a server first, because you can serve that off of a server just as easily as you can serve it locally. There's all kinds of possibilities here. We just haven't necessarily figured out which ones are going to work right for everybody. And of course, the answer is nothing works right for everybody. So. I look at the clock. It says 8:36. We've lost a few people. I think I'm going to wrap it up now. Thank you very much. I appreciate it. In exchange for allowing me to stand here with my QR code and my URL and my little pile of flyers and say we're hiring, I have brought a peace offering, which is our latest bit of swag that our recruiter, or Jenny, who's our office's person for community, got recently. And these are rechargeable USB battery packs. Please only take one. I'd like to come back with some of the box. And yes, they are branded, so you'll know it was us, and then go, hey, I really hate my job. Maybe I should go talk to those Whitepages people. Thank you very much.